Hi, Mai. So these interest problems are always tricky. And one of the things that I like to think about is just the general shape of those graphs. And they're always kind of swooping upwards or swooping downwards. And we can talk about, kind of that in a later in this little clip here. But you set it up exactly correctly. And one of the things to recognize is that it's always, the amount that your AFT that your teacher uses here is kind of the total amount that Tony in this case has in his retirement savings. So it's the principal payment, right? However much he puts into the account, right? And then over time that earns interest. So it's calculating all of that at every single year. So you put in time 0 or time 1, then the function can help you out. So it's your principal times 1, because this is growing. That's why it has to be greater than 1 plus your rate of interest. And the rate's always kind of it's not as 7%. You wouldn't put 7, you put 0.07, right? So you write it as a decimal. And then you raise it to the power of the year in this case. Like how many years would he be investing for? Or what's your term? Sometimes in different things it can be a term. So I've got it represented here. So it would be helpful, I think, to just get a couple points. So one option is totally, you ask, can you use a graphing calculator here? That's something that your teacher has to answer. I mean, if it were my class, then yes, absolutely, you could just use a graphing calculator. But I have a feeling that she wants you to plot some points out here. So let's just plot a couple points. And I think one of the easiest ways to do it is plot a couple at the beginning, because those ones are pretty easy. Plot 1 or 2 in the middle, and then plot the ending points. So you get a general idea of what this thing looks like. So the first one, whenever we plug in time 0 into an exponential, remember that a base power raised to the 0 power is just 1, right? So we have our original amount, so $318,000. And then after a year, right, so you calculate this, unless you do it on a calculator, you notice that he's already made about over $22,000 in interest, so $340,000. All right, and then I skipped ahead and I said, well, what about after 10 years? And then ultimately, because you're asked to look at the timeline 0 to 20, and so it's actually convenient that the number of ticks that you're given here is 20. It's a 20 by 20 grid. So this is kind of year 0, year 1, 2, 3, 4, 5, 6, 7, 8, 9. So year 10, and then all the way to year 20. Okay, and we'll figure out the scale for the other in a second here. All right. But then, so you notice, okay, so we've got these two amounts, 625,000 after 10 years, and then 1.23 million after 20 years. So to help with the Y scale, right, when we talked about this the other day, it's like, well, what's our range? What is the range of the Y numbers that we have to represent? So on the high side, we have a little over $1 million, $1.2 million. And on the low side, our first year, our initial investment, $318,000. Now this isn't exact, I didn't do this exactly, but it's pretty close to $1 million. All right? So basically we need to show a difference in $1 million over, and there, like I said, there are 20 ticks horizontally, there are also 20 ticks vertically. So we have $1 million that we need to represent over 20 units, right? And if we do that, we see that each tick can represent $50,000, okay? So if each tick represents $50,000, let's go back here, zoom back in here, $50,000, whoops. So we need to represent a range of $1 million from the bottom to the top. Now, if we were to start at each unit $50,000, our first unit would be 50,000, and then we'd end at the top at 1 million. The problem with that is, though, we need to be able to represent $1.23 million. So instead of starting at the bottom at $50,000, I'm going to erase this. We're actually going to start at the bottom at $300,000. Okay. So our first tick will be $300,000. All right. So and by the tick, I mean this value here, we're going to say is $300,000, and then we'll go by 50 increments. So then the first tick here would be 350. I'll zoom in more here. Then 400, 450, 500, 550, 600, 650, 700, 750, 800, 950. Now we've got 1 million, 1,050,000, 1100. Right, we're getting close here. 1150, so that's 1,150,000, 1,200,000, 1,250,000, 1,300,000. Ah, great. So now we're definitely clear. 1,350,000. Okay. So the key is to not start at 0, but to actually start where our numbers start. Okay. I know it's a little confusing, but actually start where your numbers start, and then you can represent, because there's nothing that says you can't start there. All right. Just say, yeah, this is the point 0, comma $300,000. And I would just write, dollars in thousands. Okay. So now let's just go ahead and plot some of these points whose values we just calculated over here. All right. So we'll zoom back out so we can see them. So we've got to represent $318,000, $340,000, right, all the way up to 1,230,600. All right, and these are obviously going to be approximate. So let's start with the first two. $318,000 is close to $320,000. And you notice these first two numbers, given our scale here, switch colors while we plot, we'll do it in blue. These are going to be pretty darn close. So we have 0, and if this is, so here would be $300,000, right? But we don't want that. So we want about $320,000. So it's still going to be pretty close, right? And after a year, it's $340,000. So it's increased a little bit, but it's not quite yet at $350,000. All right. After 10 years, right? After 10 years, we have $625,000. So we come back over here and we look, okay, 10, here's year 10, and where's $620,000? Okay, so it's about there. All right, there looks to be a stray mark here. I just want to get, oh, it looks like I'm not going to be able to get rid of that right now. Let's try this, just not to confuse us. All right, great. So that's my 10-year mark, and then my 20-year mark was 1.23 million. So 20 years, 1.23. So it's more than 120. So it's between 100, right, 1.2 and 1.250. So it's going to be somewhere right in the middle there. So that's my. So now I just have to connect these. And typically, like we were talking about before, these things start out slow and then swoop up. So in a similar fashion, I'm going to make this a fatter line actually. We're going to start out slow, right? And then we're going to come down here, right? And then we're going to kind of swoop up, all right? And this is effectively what our curve is going to look like. And because we've zoomed in, it doesn't quite have the same upward trajectory that I drew here. But if we had zoomed out, because remember we're representing only 20 years horizontally, while we're representing almost $1 million vertically, it would look quite a bit more stretched. All right. So absent a graphing calculator, this is what I would do. And even if you have a graphing calculator, getting a few points down is going to be extremely helpful in helping you determine what this looks like. As for the next part of the question, which asks how many years will it take for him to achieve his goal of getting $1 million and use the graph to confirm it, now we can very easily go ahead and look at, when he gets to $1 million, we can look and we can say, all right, well, it looks to be, so if that's 10, 11, 12, 13, 14, 15, 16, 17, so this is year 17, this is year 16, so we're going to guess that somewhere between year 16, year 17 or so, he's going to hit $1 million. And we can check those. All right. This says determine algebraically, right? So you set this up pretty correctly. You say, all right, we want to have $1 million as our A of t. And that means we have a 318, principal times 1.07 to some power t. Now I don't know if you've learned logarithms yet. I don't know that you have, because you can't solve this algebraically without logarithms. And if you have, then then great. But if you haven't, then that's a little bit more of a challenge. But as you did here, you can say, okay, well, you can check what happens if t is 16, or what happens if t is 17, right? And if we look at what happens when t is 16, right, you're going to find, so 318,000, I'm just doing this here, times 1.07 raised to the 16, right? So it's year 16, A of t, right, looks like 938,788 and change. And then as you noticed, for t of 17, so this is A of t again, but A of 17 really, so this should, and above, right, this should be A of 16. You notice that we draw past the million mark. Okay? So you've confirmed it.